All right, episode 6, cytotoxicity. And today we are talking about
Learning to fail.
learning to fail, learning how to be okay with failing. So something that I think a number of people could do with having a bit of
Yeah.
personal growth on.
In the end, Cyto is inherently hand in hand with failures. So that's what we're going to delve into, try to cover and discuss, as long with the different methods that are out there, the test concerns and issues, and ultimately trying to know when to use Cyto, how to use Cyto, and then what to do when you fail Cyto.
Absolutely. And touching on the power of Cyto as well, because whilst I do believe it's a overvalued test, there is a lot of power within the method as well. So
Correct.
hope you're ready. Hope you're hungry. Hello and welcome to Bite-Sized Biocompatibility, the educational series focused on making the technical content of medical device biocompatibility digestible. My name is Leah Williams.
Hi, and I'm Beau Rollins with Intrinsic Medical Group, and we're excited to take you along on this journey.
Hello and welcome back to Bite-Sized Biocompatibility, episode 6. Today we are talking about cytotoxicity.
One of my favorite and least favorite topics.
It definitely gives you a lot to think about. So let's
Dive right in.
dive right in. Absolutely.
All right. So cytotoxicity, why is it such a my love-hate relationship? I think first off, I want to dive into what cytotoxicity is, right? So cytotoxicity is one of the OGs. It is one of the tests that everybody does. And so many people hang so many critical decisions on it. And I think that's why I struggle with this test. So
Right.
the test itself is a very simplistic test. It's an old school in vitro test where we're going to be looking at naive mouse lymphoma cells, and we're going to expose them to an extract and see what they do.
Right, exactly. And actually, this is one of the tests that you see used really widely outside of biocompatibility as well. Like looking whenever you're doing a literature review. So it's more often than not that if you see in the abstract saying that we tested this material and it demonstrated good biocompatibility, they did a cyto and nothing else. And actually, this segues really nicely into a common misconception of what cyto can do. And actually, it's the only effect listed in -1 which does not correspond to an actual physiological response in a human.
Correct. It is uber sensitive, meaning that and people think that's great, and it has its advantages, definitely, but it's not clinically representative whatsoever. And an example I like to use a lot of times is with hydrogen peroxide, something that everyone generally is familiar with. And, if you get a cut, or, I was going to try to play worst case scenario, like you have a little kid and your kid gets cut and, they got this scrape and you're like, oh, let me pour hydrogen peroxide on there. And everyone likes to watch the bubbles and everything else.
Clean the wound out, right?
Yeah. And it's, you just pour it all over and it's great. If you put hydrogen peroxide in an MEM test, you will fail.
Yeah, absolutely. It'll wipe out the cells. Cytotoxicity is just a cell monolayer that you're exposing whatever chemical exposure profile to.
And for those who are new to the assays in the test, our control that we use, the positive control, is latex, which a lot of people use latex in a lot of different applications in use, but it is highly cytotoxic, which is why it's utilized as the control there. So if we play those factors kind of into, you can start to see why this test, while it has its benefits, also has severe limitations. It is because it is required more or less for everything, or at least as part of every exposure category. We do see it. There are a variety of tests that you can do within Cyto, so using the appropriate Cyto is also important. But it definitely is one not to take lightly.
No, exactly. So yeah, just the different categories of tests that you can do are your extraction-based methods, your direct contact methods, and your indirect contact methods. And more information on each of these different types of methods is available on the accompanying infographic as well. So do go and have a look at that too. And that sensitivity that we've mentioned as well, and the fact that it tends to be a really cheap and quick and easy test to run. So that can be really useful. And one of the great powers of cytotoxicity, in my opinion, is its ability to be used as a screening tool. So say if you're mostly sure that the risk is absolutely fine with a change or with your device in the literature reviews coming back highlighting no risks with irritation, sensitization, systemic toxicity at all, but you just want something as a gut feel check to screen for potential for toxicity impact, then Cyto is your go-to. You can also use it to screen for manufacturing residuals and any potential risks arising from that.
And a controversial stance that I have is that I wish we'd actually removed this from our 1093 set series. I do think Cyto has its place, as you mentioned. I think it's an absolutely brilliant trending tool. If you do have critical materials that have high potential, or maybe suppliers that you don't have the best confidence in their manufacturing processes, you can use Cyto as a batch or lot by lot screening tool to be able to look at this, to be able to assess potential changes in your supply chain, or even in certain critical processes maybe that you don't have tight tolerances or controls over. You can use this as a screening tool. We use it in cleaning all the time to be able to look at detergent residuals and such. We'll do it like on the water from the bath solution or from the devices itself, as a way to screen and monitor things. And that is brilliant for. But to be able to evaluate the biocompatibility of a final finished device for clinical use, it really has we already have so many other tests in the compendium to be able to look at things. It really doesn't have I feel like a really good place.
Yeah, I think a lot of the benefit as well is maybe more, or a lot of the value that is placed on cytotoxicity is that psychological value, because it looks like you've got another test with another passing result, when actually the information it's giving you maybe isn't so relevant to actually mitigating that risk or telling you anything about the device's safety. Well, it does tell you something, but it doesn't tell you the specific information that you're looking for about the device safety. As you mentioned, this is covered through mitigating risk with respect to the other biological effects.
Yeah.
Yeah, so you mentioned that it's a good trending tool. Do you think that actually this is something that more people should be doing within the industry, to just as kind of like a safety net to see if there are any changes or any differences that we're spotting within that biological risk?
I mean, I don't want to cause a fear or creation of a need that doesn't need to exist.
Yeah.
But if you are doing like a proper risk assessment on your device and you do have areas that have risk that you want to be able to control, like we do this in sterilization all the time, where we'll set up and do bioburden monitoring of critical processes and flows or changes to be able to assess those. This is a test that fits right into that regime, right? So if you do have a very critical material or device, and you know that your processes around it are not that robust, then this is one of those tools that you can implement. And I'll go back to the cleaning, because I think it's really, there's a cleaning standard out there for orthopedic implants, 19227. And yes, even though it is orthopedic implants and you might not be in that realm, it's one of the only cleaning standards out there, but it does list Cyto as a tool to be used as part of your validation and continued monitoring or verification, because it acknowledges that the ability that Cyto has, being so sensitive that it can pick up detergent residuals and manufacturing residuals that have cytotoxic potential.
Right.
It doesn't mean that if you fail a Cyto from a cleaning validation that your product or your device is going to hurt a patient. It's about screening and monitoring.
Yeah, absolutely.
And that's where that sensitivity can really come into play and really kind of help with doing that, because there's not really great ways of assessing like certain detergent residuals or manufacturing residuals, but this test does.
And often you find that, there should be a lot of control around your clean room environments and not, but often in biocompatibility, you find that a lack of understanding from other people. They assume the word like for like and equivalent, which we could spend a lot more time talking about. They assume that one manufacturing like detergent or a cleaning product that they use in the clean room that doesn't touch the product, that they can just exchange it with another sometimes. So this is a really powerful tool, this cytotoxicity test. It's also cheap and quick to do, and pretty simple to set up as a routine thing that you can do for screening. And I think it's something worth considering, especially with the latest revision of -1 as well, which has a much heavier focus on life cycle management and actually evaluating the biocompatibility throughout the device's life cycle as well. So this will really allow you to capture or have a little bit more of a quick capture to see where it's going from. But again, don't want to put any unnecessary risk or make a backroad for anyone.
This is where things get sticky, because when we look at life cycle, or if we want to look at really any sort of cytotesting and potential failures that come from it, what does that mean? So I'll give a couple examples here as we go through, because they all are kind of, fit into this realm and issues around failures. But if we start with life cycle, because that's where you ended, if I have product that I'm going to be testing, whether it's accelerated age 5 years or especially the real-time age 5 years, and I'm going to say, hey, I'm going to do a cyto and see, I strongly caution against using cyto as your tool to evaluate life cycle, because it is so sensitive. There's aspects that, like packaging materials, if they were gamma radiated over time, especially if it's like polyurethanes, and that will release radicals, and these radicals will cause you to fail your cyto, but they are not clinically a risk. Right. So if you wait and you have cyto as your life cycle verification tool, and then you get to that 5-year age sample and you test and you fail cyto, what do you do?
Yeah.
Right. You've now set yourself with a super sensitive test that's picking up something, yes, that has changed, but it's not of clinical significance.
Right.
And so with that, you want to be very cautious. I've seen this as well with devices that people have run cyto over time, like they want to go back and just check something, or they had potential like risk or concern with the device and maybe manufacturing residual, and they're like, okay, we've got product that's out in the field. Let's call some back and do a cyto on it. Mm-hmm. And they'll run a cyto and the cyto will fail. And now they're saying, oh crap, we got to recall product.
Yeah, right. Exactly. A cyto failure does not mean that you've got a significant risk to your patients. It's a fantastic, very sensitive screening tool that can be used to indicate if you need to do further investigations, but you should not take it as the be all and end all.
No, and I'll just flat out say, please do not ever make a recall decision based off of cytotoxicity. It is not an appropriate test to make that determination.
Absolutely not.
It is not evaluating actual patient risk unless you just want to be, just don't do it.
Yeah.
That's probably the best way to just say is just
absolutely.
Don't do
it. I think that's a really, really strong message that we should definitely be pushing out there. Now, I think that's a...
Oh, go ahead.
No.
No, I was going to say, so now this kind of segues into, if I do have failures, what do I do?
Well, it's definitely not, as we said, it's definitely not a cause for panic in any reason, just because what cyto is that a really sensitive and useful screening tool. And it does maybe indicate where you do need to further evaluate your biological risk. However, it can actually also tell you a lot of information, that failure. And it doesn't, as we have said, and you're going to get bored of it by the end of this episode, it doesn't necessarily mean that you've got an unacceptable clinical risk with your device. So use that data from the cyto failures as well to give you more information about how maybe the cells responded to the exposure of the device. Use that information to see maybe were they suffocated? Did they start getting granulated? Are they staying intact but are just maybe detaching from the surface as well? So any kind of qualitative information that you get from the cytotoxicity study as well can be super informative for your future decisions in your biological evaluation plan as well.
Yep. No, you hit some key points that unfortunately isn't common practice. So when you do have a cyto failure, most people don't know that you can go back and actually get a lot of information from it. It's one of the reasons why, for me personally, being old, I prefer the MEM elution test. A lot of the current approach, more modern approach, is the MTT-XTT, because that's used as part of the analysis is done through a spectrophotometer.
Right. So, and then just jumping a little bit on the details there, like that MTT-XTT approach, because the analysis is done on the spectrophotometer, you're getting more of a quantitative outcome there, where it gives you very much a black and white, this is the answer, this is your degree of cytotoxicity. Whereas with the MEM elution, you're still getting a semi-quantitative reading out of it, but it's very much based on that qualitative observation of the cell monolayer as well. And just to note that with MTT, XTT, you can still get that qualitative aspect as well. But often when you're working with the labs, you do need to request that they take images of the lab, of the cell culture that you've got, and therefore also interpret what the cells look like and give you a bit more information based on that.
Yep. No, and timing and all these are very crucial. So I guess if we're going to talk initially kind of on the MTT, XTT, unfortunately, hindsight's always 20/20. The only time you can really get any information on the cells is if they look before they add any of the dye, any of the actual MTT or XTT to the cells. So they do a read at that time, and they'll note if they see anything, but a lot of times they don't always look that closely. Not any knock on any lab or whatever, but they're more leaning on that reading of the dye through the spectrophotometer for
because it's such a
test
common
analysis.
test,
Yep.
they've got hundreds.
Yep,
and hundreds
they're just trying to crank
churning
through. So they may not notice particulates, they may not notice, cell reactions to some of the other aspects, but that's the only time they can really read it, because once the dye is there, they can't. The other kind of down point to the MTT, XTT is that you can have cellular distress where they create granulomas and that dye gets trapped, and so you actually read it as living cells when actually they're not.
Yeah, that's a very good point.
So there is, no test is perfect when we go to look at this. And like so with the MEM elution, it is very subjective. I mean, it will always depend on who's reading it. And they're usually erring on the side of caution, most labs are, right? And they're trying to gauge on a percentage of viability based on what they see. However, they are able to look, like you mentioned, for a lot of those distress aspects. And so that can help you in your investigation know, is this a chemical? Is this an oil? Is this some other, reason that's causing these responses? So there's value in each of those. There are a lot of other methods out there. We talk about the agar overlay, where they put a thin layer of agar on top of the cells to put a device. That generally is accepted globally, except for the US. So the FDA doesn't accept that because we've never been able to validate what the agar will let diffuse through.
Right, exactly. If it's water soluble, then chemicals will be able to come through, but then you miss out all of those non-polar and constituents as well. And that agar overlay, difference in pronunciation there, is part of the indirect contact methods. And another indirect contact method, which is listed in -5 as well, but from my experiences, I've not seen it so frequently, is also the filtration separation or filter separation method, where you grow your cell monolayer on the filter, place it upside down, and then put your device on top of that filter as well. So that can help overcome that obstacle with the diffusivity of constituents through the agar.
Yeah. And then we have direct contact, which is either the extraction, which is going to be like with your MEM and MTT and the extraction solutions put into it.
That's an extract-based
I
method.
guess that would be an extract-based method. Or the direct contact, where you're going to actually put the article itself within the well and expose it. Generally, from my experience, this is just done with contact lenses, because any heavy-weighted material and things will cause either physical damage to the cells, or keep in mind that there is slight vibrations when incubation and stuff, so they can actually cause some shearing and physical aspects on those cells.
And that can result in failures.
Correct.
Yeah.
Yeah.
So just going back to those failure aspect as well, the having a look and seeing how exactly the failures have occurred through observing the cells is really critical information that you can use to inform other biological tests as well. So there's a number of other in vitro methods that are used for mitigating risk with respect to other biological effects as well, which are based on cellular exposure as well. So if you know from your cytotoxicity study that there's maybe an oil in there and it's going to suffocate your cells, or there's some sort of material incompatibility, that can be used to determine which methods you use for those future effects.
And other things to look out with failures is you could have pH that should be detected with the pH indicator, because neutral red is usually what's observed to look for. We want to keep the pH neutral. But a shift in pH will cause issues as well as osmolarity. And some of these are not easily identified, and definitely the lab's not going. They should observe a pH change based on the color of the solution. However, like osmolarity isn't something that would be, and so some of those can play into a lot of potential failures. The other thing that you'll see on labs as well is that the extraction is done with culture media, but what like bovine serum and what percentage is used is not.
Yeah, that's all variable.
It is very variable. There's usually a minimum. So let's say if there's a minimum of 5% bovine serum that's required, that bovine serum actually does a lot of buffering aspects, but a lab may use 7% or 10% instead of the minimum 5.
And
the
that
5
really has an impact on
huge
on how well the cells do as well.
And so it does. A lab that runs 5% will show more failures than one that runs 7 or 10. And so that's something that's not disclosed or really discussed, but it is something to be aware of, and why you might test at one and be like, I passed, and then I tested at this lab and then I failed. I don't understand. It could not have anything to do with your device, but with the lab itself.
And the specifics of the methodology, and often that is intellectual property for the lab as well. They don't share those specific details. For example, like if you're looking at the agar overlay method, they don't share how much agar is used in that. So that's definitely one thing to watch out for.
So our ultimate, I guess, summary on this is, one, Cyto, it's part of the process. It's part of the system. So you're going to have to use it and embrace it, but don't panic from it, especially if you get a failure. And the more you understand and know about it, and using the appropriate Cyto test for your device, knowing the lab and how they're going to be doing it, is all critical factors to play into whether you're going to be successful or not.
I actually did have something else I wanted to add.
Oh,
that's
good.
Not on the list.
No, by all means.
I think one of the things that has been my biggest question about cytotoxicity studies is the type of cell used as well, the cell line used. So the classic cell line that's used, that you see pretty much everywhere in industry if you get a cytotoxicity study, is the mouse fibroblasts.
L929.
L929 cells. And I've started asking some questions of why we use this, because looking over -5, there is no specification that you should be using L929s or any other type of cell. They just say that it needs to be a validated cell method. So one thing that I've really gotten to questioning on, and one thing I'd quite like to see the industry doing instead, is validating maybe a human fibroblast line to make that data more representative to the cell types that are actually seen in humans as well.
It's a very good point. There are, I've seen more recently with a couple labs developing and bringing up new cyto lines that don't use the L929.
Oh, yeah. What sort of cells are they using for those?
Off the top of my head, I'm not going to be able to recall
No,
off of that, unfortunately.
I think the obstacle that, because you can use any validated cell line, but that's the key word there, validated. You have to invest that time and the money to validate it. And we see in industry that, especially with the push to kind of like bring devices to the market, it is at the end of the day also a business. Whilst our primary objective is patient safety and improving the lives and quality of lives of patients, medical devices is still a business. So a lot of people aren't willing to spend that time and that the financial investment either into validating those different cell lines.
Yeah. And that's a good question that maybe in a future bite-sized get a little bit more technical in, is why the L929s, right?
Yeah.
It might be that they're more robust, or it just might be as well that they were more commonly used back when this was the first kind of evaluated and looked at. But it is industry norm to use L929. So I do want to stress that if you do or did go to use a different cell line, be prepared potentially for regulatory questions.
Justify it.
Yep.
As
with everything to justify. So it will just raise one more question. And then also be prepared that even though you shouldn't panic with the failed cyto, you will get questions. And I even see questions come up when you get like a 2. That's technically passing, but a regulator will ask, why is that okay? You're seeing up to almost 50% of the cells responding. Why is that okay? So prepare for those types of discussions and questions. because they will come with this test and with these results.
Yeah, and the 2 being in reference to the grading used to the
That is a good fair
the
point to acknowledge, is that we haven't talked about the scoring behind here.
right.
But the scoring on a Cyto, yes, is from 0 to 4.
Yeah.
0 to 2 being passing, 0 meaning that there's no observed, 1 0 to 25% cell response, 2 25 to 50, and then 3 and 4 continuing on the scale up to
Yeah.
complete.
And it's actually a really good point, and I really love the fact you used the word cell response there rather than cell death or cell viability, because cytotoxicity isn't just looking for whether the cell dies or not. It's looking to see what responses it has in terms of like granulation or other stress responses that might be exhibited by the cells, and that's where that qualitative assessment also really comes into it as well.
Yeah. So, as you'll find as you delve into biocompatibility, obviously I'm speaking to all the readers, not to you, Leah, necessarily, but every one of these parts, these effects that we evaluate, have immense complexity going into decades of science and reasoning behind a lot of these things that sometimes make sense, sometimes don't, but always have impacts.
Yeah.
And so the more that you can learn and educate yourself on these going through, the better off you'll be in setting up and conducting them successfully and troubleshooting them when you have issues. But I can confidently say to anyone who steps in the realm of biocomp, you will have failing cytos that you will
Yeah.
have to deal with. So it
Yeah.
is one to embrace.
Yeah, embrace it, don't panic, use the information that it gives you, because even a failing result tells you something. Cool. All right. Well, thank you very much for joining us for another episode of Bite Size Biocompatibility. We hope you enjoyed it. And if you have any questions whilst you're digesting the information from this episode, please feel free to reach out to myself and Beau at any time via LinkedIn, or we'll drop our emails in the caption below. Until next time.